All right, let's just jump right in. For the very first time in human history, we actually have the tools to measure our true size, our true place in the universe. And the answer, well, let's just say it's more than a little unsettling. And that's not some philosophical quote. It's a statement of fact. And you're about to understand just how profoundly true it is. Because right now, wherever you are hurtling through the void at a speed your brain was never, ever designed to comprehend. So let's start with the first layer of this reality, the motion that you can't feel. I mean, think about it. Your drink is sitting perfectly still on the table. Nothing seems to be moving. But every single instrument we have tells us you are absolutely screaming through space. And get this, these speeds, they all stack on top of each other. So you're on this rock, Earth, spinning at over 1,600 kilometers an hour. That rock is whipping around the sun at 107,000 kilometers an hour. That whole system is careening through the galaxy at a ridiculous 828,000 kilometers an hour. And the entire galaxy is being dragged towards some gravitational anomaly at a staggering 600 kilometers per second. Not per hour, per second. So you have to ask the question, right? If our senses can fail us that completely on something as basic as motion, what happens when we start talking about scale, about size? Well, the answer starts close to home, but trust me, it is not going to stay there for long. Let's start the journey outward. And this is where our everyday intuition about how big things are just completely shatters. We'll start with something familiar, our home planet. Earth feels enormous, right? Just unimaginably vast. But you could fit over 1,300 Earths inside Jupiter with room to spare. In fact, Jupiter is so massive that it doesn't even technically orbit the sun. They both orbit a shared point in space just outside the sun's surface. But even Jupiter is a pebble. Our sun could swallow 1.3 million Earths. And here's the real kicker. Astronomers classify our sun as average. It's ordinary, a totally unremarkable star. So if that's average, what does a remarkable star look like? It looks like this, a monster. The hypergiant star UY Scuti is so vast that if you put it where our sun is, its surface would extend out past the orbit of Jupiter. Light itself, the fastest thing there is, would take over 8 hours just to travel around its circumference once. But it's the distance between the stars where our brains just break. To make it tangible, imagine our sun, the one that fits 1.3 million Earths, is shrunk down to a single grain of sand in Lagos, Nigeria. The very nearest other star, Proxima Centauri, would be another single grain of sand in Accra, Ghana. That's 2 tiny specks separated by almost 600 kilometers of absolute total emptiness. And our galaxy has up to 400 billion of them. Now, when we zoom out from that impossible emptiness, we start to find our true cosmic address. And it turns out we don't just live in a galaxy. We live inside a giant cosmic web. So you've got our Milky Way. It's just one of over 80 galaxies in a little cluster we call the local group. Think of it as our galactic neighborhood. But that whole neighborhood is just one tiny node inside the Laniakea Supercluster, a colossal structure that contains roughly 100,000 other galaxies. And here's the wild part. We didn't even have a name for our own home supercluster until 2014. That's how new all of this knowledge is. We are residents of immense heaven, and we live way out on the edge, a suburb of a suburb. See, at the largest of scales, the universe isn't a uniform fog of galaxies. It's a web. All the matter, all the galaxies and stars, us, it's all concentrated in these long, thin filaments. And what's in between those filaments? Voids. Gigantic regions of almost nothing that make up about 80% of the entire universe. Most of reality is empty space. And along one of these filaments sits the largest thing we've ever found, the Hercules Corona Borealis Great Wall. It's a single, connected structure of galaxies that stretches 10 billion light-years across. That's more than 10% of the entire observable universe. And according to our standard models of physics, it's impossible. Nothing that big should have had time to form since the Big Bang. But there it is. The universe, it seems, doesn't really care about our models. So we've looked out at the infinite expanse. But there's another direction that's just as deep, just as mysterious, the journey inward. You think of your body as a solid object, but it's not. It's a temporary collection of about 7 octillion atoms.
That's a 7 followed by 27 zeros. You're basically a complex cloud of particles, held together by electromagnetic forces. And what are those atoms really made of? Mostly nothing. This analogy is just perfect. If you blew up a single atom to be the size of a football stadium, the nucleus, the actual stuff, would be a tiny grain of rice on the 50-yard line. The electrons would be like motes of dust floating around in the nosebleed seats. Everything in between is just empty space. You are almost entirely void. And if we keep going down, we eventually hit a wall. It's called the Planck length. This is the theoretical bottom, the smallest possible unit of space. It's the scale where our two greatest theories of physics, general relativity and quantum mechanics, give us completely contradictory answers. Below this, space itself might dissolve into a kind of foam, something we don't even have the language to describe. Okay, so we have this infinity of largeness stretching out above us, and an infinity of smallness stretching down below us. And this brings us to the final and maybe the most disturbing reality of all, your actual place in the middle of it. This is the startling truth. When you look at the ladder of scale, from the smallest possible thing we can even conceive of, the Planck length, to the largest thing, the observable universe, a human being sits almost perfectly in the geometric middle. Not at the bottom, not insignificant. You are the center point. And that's the profound implication, isn't it? We exist on this razor's edge of scale, and we seem to be the only structure complex enough to be aware of the whole ladder. A quark can't contemplate a galaxy can't examine an atom, but you can. You're not just in the universe, you are the universe, aware of itself. And this is our literal connection to it all. Every fundamental element that makes you wasn't made on Earth. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, it was all forged in the heart of a star that lived and died billions of years before our planet even existed. And it was scattered across the void to eventually become, well, you. Which leaves us with one final, deeply unsettling question. How can that temporary arrangement of stardust, that 1.4 kilogram brain inside your skull, look out and comprehend a structure so vast it shouldn't even exist? We sit at the exact midpoint of all existence, looking both up at the cosmos and down into the quantum realm. So is that just a bizarre coincidence, or is it the entire point?